evening, everyone, and thank you very much for joining us tonight for this webinar about remote construction and real estate monitoring. It's a real pleasure to have you all on board for this exciting webinar. So my name is Samantha. I am the sales development representative at Picterra. And tonight I will be hosting this webinar with my colleague Caroline, who will present herself now. Good evening, Caroline.
Hi, nice to meet you, everybody who's joined us tonight. So thank you for joining. My name is Caroline Bailey. I'm the account executive at Picterra and looking forward to talking about the construction industry today.
Thank you, Caroline. So a little bit about Picterra. We are a Swiss company based in Lausanne. It was founded 5 years ago by Pierre Polena, CEO, and Franck de Morcier, the CDO, with an innovative mission in mind to democratize Earth observation and empower your data thanks to artificial intelligence and machine learning for better decision-making. Picterra is industry, location, and data agnostic. We live in a world that relies mainly on data. You probably have a lot of data yourself today, and Picterra allows you to extract repetitively occurring objects of your choice from a 2D image. For example, you might want to monitor the vegetation evolution close to rails for risk mitigation, or the electricity network. Or you can't visit construction sites regularly, but have to report to your clients on your project advancement. You might also be looking into road cracks for predictive maintenance, resource allocation. Just think of any areas you want to highlight the edges of, or individual objects you want to extract. Anything your eye can see, the machine will detect. The images you work on can be satellite, drone, or aerial. Satellite imagery is provided at the moment from our partners, Airbus and Skywatch. You may also have your own UAV program at the moment, so you already have the images available. If not, Picterra can put you in touch with third-party service providers who will help you collect image from UAV or from airplanes. Don't worry, Picterra has been designed so that anyone from your company can use it. You don't need to have a technical background, and if you're curious enough and willing to learn a new skill, you can create detectors and generate your own reports. Project managers, architects, customers, really anyone from your company can use Picterra. That's not the only thing. We understand that you might not want to add another tool to the table, and you probably don't want to flip completely your workflow that you already have in place and that is already very efficient. This is why we have made it really simple to add Picterra to your own workflow and integrate it to your existing tool, ArcGIS, AutoCAD, BIM processes, etc. Now, Caroline will go into the more technical explanation of our platform and what it can do.
All right, well, thank you very much, Samantha. Really appreciate the introduction. As presented, we're both on the sales team at Picterra. So this is us. We'd like to thank the whole Picterra team for all the energy they put into the product at all times. So the Picterra workflow, as Sam was just describing, what we do is start with the data input. So this is images in our case. We're talking about all sorts of top-down images, 2D images, either from satellites or increasingly from drones. What we do is to be able to put those images into our platform and then create detectors of your choice to be able to extract repetitively occurring images. The output is then shape files, object counts, and reports that fit into the different workflows that you already have in place. Because as Sam said, we don't want to just create more data for you, but really be able to fit this into existing workflows. So throughout this presentation, what we're going to do is show you some examples of detectors and also how they fit into workflows and be able to talk about those things in a meaningful business sense.
Thank you, Caroline. So we will talk about various clients that have trusted Picterra so far. So we worked with Strabag. It's a Swiss construction company. We also work with SBB, the Swiss rail company, with the UN, with the City of Hong Kong in urban development. We've also collaborated with the Swiss Tax Department office. Today, we're focusing on the remote construction monitoring. What's remote construction monitoring? In this industry, remote monitoring means using tools like software platforms, webcams, sensors, and drones to track progress, plan, and adjust timelines. And you can streamline processes from anywhere in the world. Some of the benefits of construction monitoring remotely is to reduce the mistakes and rebuilds, to allocate your resources based on real-time data, have faster insurance approval. You can do 24/7 inspection automatically. You can cover multiple sites at once using geospatial data. You can access your site wherever, whenever, from the comfort of your office or your home office in that matter. And you can reduce your carbon footprint by traveling less. If there is one thing that we've learned from the current pandemic situation, is how crucial it is to be flexible and to digitalize processes. The pandemic situation has massively impacted construction sites in every region of the world. Apart from the key workers whose presence is mandatory and allowed on site, it has become more and more difficult for managers, architects, and customers to travel on site to track the progress regularly. Although this might appear as a challenge, it is actually a great opportunity to push harder on remote monitoring, which brings high value to resource allocation and cost-saving strategies. This is where Picterra can help you take one step forward in your transformation strategy and help you overcome your day-to-day and operation challenges. We can help you save costs and make better decisions based on your data. We will now walk through 4 of our main capabilities. First one is scheduling and mistakes tackling, as built versus as designed. 40% of a construction budget goes to rebuilds. To lower that delta, thanks to remote monitoring and object extraction. So Caroline will now explain how you can anticipate such issues and collect proof.
All right, thank you, Samantha. So yeah, we've got a few different examples lined up for you here to explain the real things that Picterra is doing in the construction industry. First one being scheduling and verification. So you can see on the screen that there's two time points in a project. This was a construction project to build solar panels. And what was done here was to fly at regular intervals throughout this project to be able to monitor what was going on. So what we've done is set up a detector with the client to be able to extract each solar panel as it's being built. They're quite regular objects, so this was a good example that worked out really well in the end. This is just the start and the beginning of the project, but actually there was many more maps like this appearing in between. And what we could do is not only see the total area covered by the solar panels and count how many there were, we could compare that to the schedule. So there's a plan every day for what should be built. And by extracting this kind of data, you can automatically, behind the scenes, compare what's been built to what was designed. So as built versus as designed. And that fits into your workflow. We can organize for just reports or emails to be sent saying, yes, this has been done every day versus what should have been done every day. So this is a nice example of how you can use AI to streamline what's really happening versus your schedule and spot mistakes early. As was said, like a lot of money is put into correcting mistakes. If you can automatically be alerted when something has not happened on time or should be happening and see who is responsible, if you've got many different contractors on the site, that could save you a whole lot of time with rebuild and of course cost of materials, potentially lawsuits. So this is the kind of thing we're starting to work with increasing number of clients on. All right, let's go on to the next topic.
Thank you, Caroline. So the next topic is now decision making. So thanks to real-time data, you can react faster and allocate your teams at the right place at the right time. Your decisions are based on specific reports on site and no more on assumptions. Caroline can elaborate on that.
Exactly. So what we see in front of us here is a site. This time it's at the same time. So both images are the exact same picture. And what we can do with Picterra is design different detectors to pull out the things that you can see that align specifically to the aforementioned schedule. So one thing we've built a detector for here is the formwork. There are various different points of a classic build that are very eye-catching. So earthworks, formwork, concrete poured itself, scaffolding, all of these things, putting a roof on, putting solar panels on the roofs. These are all things that can be photographed and therefore detected automatically because they're very distinct. So what you can see here, for example, on the left-hand side, you can see the formwork and you can see the concrete that's partially been poured. If you want to compare this to your schedule, it could have been that this was correct, but it also could have been that that concrete should have been 100% poured when this photograph was taken. So what we'd be able to do here is say, we've identified formwork, it's covering specific areas and they do or do not match to the plan that you created for this day, and then alert you to whether that's correct or, more importantly, not correct. We move on to another example here. This is a construction site. This time we can see, or many things, but we can see piles. So piles, for people that might not know, are the foundations of skyscrapers or any tall buildings to protect them against lateral load from wind. So they go down a very long way into the ground, maybe 60 meters if it's a 100-meter building. They're made of concrete and wire, and what we can see at the top here is the tops of them. So on the right-hand side, you can see we've created a detector to pull all of those out automatically. So again, there'll be a certain number you're trying to find or expecting to find that should have been built at a certain point on a certain day. If the number of detections don't match your plan, you need to know about that as soon as possible to check what happened. So this is another example of how we could automate systems to give you information to make better decisions faster. All right, let's move on. Predictive maintenance.
So for those who are not familiar with predictive maintenance, it's the range of techniques that are designed to help determine the condition of in-service equipment in order to estimate when maintenance should be performed. This approach promises cost savings over time or time-based preventive maintenance because tasks are performed only when warranted. And this, of course, is enabled by AI and object extraction. And rail industry is switching into predictive maintenance very actively at the moment. Caroline, can you tell us more?
Absolutely. So I think this highlights a really key advantage to using Picterra. The point of using artificial intelligence and machine learning is to really replace a human's repetitive effort. Predictive maintenance is repetitive. It's something that you're going to have to do on a regular basis for the rest of an asset's lifetime. So at the minute, we're thinking about rails with people walking up and down rail tracks, which is dangerous as well as time consuming, or on roads, people driving up and down with vehicles looking for cracks in roads, manually marking the number of cracks in different areas that they need to be resurfaced. What we're looking at here is vegetation encroachment between rails. So this was a real example with a client that we did in Switzerland with SBB that we mentioned earlier. But this is a case that I've heard of with many clients across the world. Weeds continuously grow, different kinds of vegetation grow. This was actually an invasive species. And what happened in this case was that the client was able to fly with a drone. We were able to detect these particular weeds. And then the client was able to act by, in that case, sending in a train to actually spray the lines with boiling water to temporarily kill the weeds. They did that on a fairly regular basis. On the right-hand side, we have a road crack detector. So that's being done to find where roads need to be resurfaced. We can find road cracks, we can find potholes, we can find road markings, and also you can see the manhole covers there on the roads. These are all the kinds of things, including street furniture, that we could detect. The more interesting point, I think, is what you do with all of these detections, because do you really want to know where every single crack is, or do you want to know when you should go and resurface a road? So by extracting the cracks, it's then very interesting to compare these to threshold values, at which point a resurfacing project should be started. So for example, are there a certain number of cracks, like a density of cracks within a certain area of road, or have certain ones exceeded a certain value which indicates danger, like potholes are too big, cars might get damaged, we need to resurface. And that's the kind of decision that you can automate with this technology. Okay, let's move on. Next one is land assessment.
Thank you, Caroline. So governments have established very strict rules in terms of environment protection and sustainability, specifically in urban planning. Land assessment is just one parameter that construction companies have to comply with. Vegetation monitoring, for example, can help you comply with the ESG rules.
Yeah, so as we've said, there's lots of different objects you can extract using Picterra, but land assessment is another important thing that we can also help with. So classifying different kinds of land is very important at the beginning of a building process, potentially during and after as well. But for finding what the status quo is before you start design work, before you start earthworks. So in this particular situation, you can see 4 different detectors that we've created for different land classifications. So we have green, which is the trees. Red is the parkland and gardens. The yellow is all of the paved areas, so that includes roads and driveways. And the blue is the water. So this was done with fairly high resolution data, but not extremely. This can be done with data collected from a drone or a plane. In this case, it was a plane, potentially also with satellite data. Although the higher the resolution is, the more you can see. The higher above the ground the object is taking the image, depending on the camera type, the resolution is lower, and therefore you can see things in less detail. So with a satellite, it's more relevant to expect to see the outlines of houses and the general positioning of roads, but definitely things like where is forest versus where is urban area, or where is mountainous or where is water. If you wanted more precise land coverage, like what types of crop are grown in certain fields, you may need more accurate, higher resolution data, and that would need to come from drones or aerial craft. Okay, let's move on to the last situation. This is environmental, social, and governance, so ESG.
Yes, thank you, Caroline. I will let you go into this one.
Yeah, sure. So this is, again, something that needs to be done generally before building project starts, maybe afterwards to assess the impact after a build. But definitely it's of increasing importance these days to assess how any construction site is going to affect the immediate environment. There are various ways that Picterra could help with this. These are examples of counting trees. So counting trees and counting crops is something that we can do too, which is potentially less relevant to construction. But if you did need to cut down certain numbers of trees to make way for highways or for any construction, then this could be of relevance to see the general amount that would need to be replanted somewhere else to carbon balance. Other things that we have detected for these kinds of projects in the past are animals' habitats. If you want to build across a protected habitat, you're going to need to fight quite hard for it these days. So looking for birds, nests, different kinds of trees that birds or animals might live in, hedgerows, also burrows can be detected. So anything you can see in images could potentially be detected and pulled out so you can assess the magnitude of the problem that you're going to be dealing with. All right.
Thank you very much, Caroline. So to sum everything that we've just said, the main message that we're trying to deliver here today is be flexible. Empower your data thanks to AI and machine learning so you can make better decisions to allocate your resources more efficiently and save costs. You can also save human errors. The best benefits for a construction company to go remote in monitoring are to avoid rebuilds that are very expensive, to avoid mistakes, human errors, and to monitor multiple sites at once and in real time in a world where field visits are becoming more and more difficult and expensive. And you can integrate Picterra into your existing workflow and make your life much easier when managing large projects. You can also think of other options with Picterra. For example, real estate opportunities spotting. We have a Swiss company who is looking into tennis courts as potential building and construction sites. Anything is possible with Picterra. And so at this point, we would like to answer some of your questions. You can type your question directly in the chat and we will answer them.
I'm going to kick off by addressing something that I know people will be wondering, which is to repeat what kind of data can be used to as input into Picterra. So we've mentioned a few different things. We've mentioned drones, satellites, also planes, helicopters. Picterra is really well set up to be able to take 2D data, which looks top down. So if you have a go on the Picterra website, which enables you to set up a free trial, for example, to have a play, then you'll be able to upload your imagery and start annotating and designing your own detectors by literally drawing around the objects of interest. We've got some good help sheets, and we've also got Picterra University, which can help you learn how to use this software. The different resolutions that we can use are completely varied. I mean, it doesn't matter. We can take any kind of data. So from satellite 10-meter resolution down to very, very high quality drone data taken above train tracks, for example, which might be down to the millimeter accuracy. That doesn't matter to the platform. What matters is that you can see the objects that you would want to pull out. Because in the end, it's you, a human being, that has to teach the software how to repeat your efforts. So if you want to count houses, that's fine. But if you want to outline houses and you can't see them well enough to do it, then you're going to need better quality data to give accurate input to the computer and to train it.
Thank you. Sorry.
No, I was going to say, I hope that covers that.
We have a question.
Yes.
Have you calculated the human hours that Picterra has saved for clients?
That is a really interesting question. I mean, we haven't, based on, it's such a large question because this does so many different things, that we have ideas of the number of people's time that this would save. But it varies based on the actual thing being detected. So I know for a fact that some of our clients have employed whole teams of interns or junior staff to count things like cars, to count things like trees. It's hard to know how much of their time they would take to do the job in the first place if they were 100% efficient. But you also know that people are not 100% efficient and will make mistakes if they're doing repetitive tasks because they get bored. And that's a real thing. So it's hard to say a person would actually take this long to do a task, but you can be sure that this software, once it's been trained, so the time investment is upfront in building the detectors, then you have a tool for life. You can keep improving it, but basically it's there. You can keep running it across any projects going forwards, and the input is press and go. It will take between minutes and hours to get you results each time. So that's the time saving there, which means you can employ those people to do more interesting things, which will be more interesting for them, but also get better results for you for their paychecks.
We have another question. So how does the pricing look like? Based on time or what image, if I have my own images? Thank you, Krister, for the question.
Great, good question. So it's based on megapixels processed. That means if you consider an area, you're looking at the area and the resolution of the data used for that area. That creates a situation, as I like to call it. So area and the resolution. You're running a detector across that situation a number of times. So either different detectors or the same detector multiple times. If you wanted to start a project with us, we would do some math with you, ask you for some different criteria and do a basic outline of your consumption needs. And we would price based on that. So we do have a standard package, which you can see on our website today, called the professional plan. That starts for budgeting reasons at around $10,000 a year. So you would need to budget that in. And if your needs exceeded the processing that's included with that, then we would ramp up to what we call an enterprise solution and really know what you need to achieve before quoting you for that. So we'd work with you very closely to make sure you get the best possible tool and also service to meet your needs.
Thank you, Caroline. We have a very good question from Elvio. Is there any other benefits other than tree counting in agriculture?
Yes, so tree counting is, let's say, an obvious one, and it's one that can be done very well, especially when we're looking at a plantation, because the trees can be planted in straight lines, very regular. Another interesting thing is looking at crop rotation. So if you know that certain numbers of crops are planted within a 10-year period, you can make detectors to find each of those crops. And then every year be scanning your area to see where is that crop this year. And I mean, that is, I'm talking about your area, but really we're talking about large areas there where you want to see over a country, or at least a county, maybe a state, what crops are being grown in what quantities and how they're being rotated. That's especially important when you're thinking about environmental impact, because you can't keep growing the crops in the same place every year. You also need to leave things for some years to increase the fertility of the soil. So to be able to prove that that's really happening, or to monitor what's happening in an area you're responsible for, that's extremely important. I think also protecting wildlife, so allowing forests to become natural again after plantations of been used and trees have been cut down. That's important. So wild forest, the reintroduction of natural water as well. So letting rivers renaturalize, or ponds or lakes increase in size, also very important.
Thank you, Caroline. Sevim is wondering if it shows residential areas on the land use map, and if so, in what color would it be displayed? And are such maps used for city plannings?
Okay, so you can, yes, you can do a lot of things around urban planning. So outlining houses would be one thing, but also looking at all of the aspects owned by the taxpayer that need to be controlled and replaced and maintained by a municipality or a city council. So we're talking about street lamps, benches, manhole covers, anything you find in the street between privately owned properties, so in the middle of the street, including the street itself, the road markings, the maintenance of the surface, as we've mentioned. All of those things could be detected using Picterra. Again, you just need imagery with many examples of these things to teach the software what to find repetitively. And so that means you could create maps which include layers of all of those different aspects. So I think outlining buildings is a very important aspect, and you would obviously see that on a map, but it depends what you actually need to work with in the end. Do you just need to see where the roads are and the buildings, or do you need to see all of the different things involved in the planning and maintenance of a city?
Thank you, Caroline. Speaking of, Speaking of recognizing buildings, Jan would like to know briefly the training phase and the typical number of iterations that he would have to make.
Great. So here we're talking about building a detector yourself, which is what we do on the platform. And again, I would encourage people to get a free trial and have a go at doing this. Very simple. You can learn within an hour or so how to do it and really become self-sufficient within 2 days. So what you would do if you had what I'd call a low risk detector. So that's where we're trying to find objects that are very repetitive. Could be cars, counting trees in a plantation where they're regularly spaced, counting containers at a port, that kind of thing. There you would need, I'm going to say, upwards of 50 annotations. It's hard to ever give an exact number, but you should assume maybe 50 examples of the thing you want to find. It's unlikely you'll get it correct with the first iteration, and by correct I mean get the accuracy you're hoping for, but actually we have seen some examples where the object in question was literally the same, like street lamps are all exactly the same. So then it was like 1 or 2 iterations. That's the best possible scenario. If you're finding something I'd call a high risk detector, so something that's more varied, like road cracks, like buildings in some cases. On some streets, buildings are all the same, like every house is the same design, but on some streets, everyone is different. If you're finding those things, you need to just keep giving lots of examples. I'd say into the hundreds of examples, depending on the variation involved in your object of interest. And that can be the time-consuming bit when setting up a detector, because you need those examples. So you need to find those examples in your imagery to start with and annotate them. But like I say, once you've built that detector, so maybe that takes you, instead of an hour, maybe that takes you a few hours or a few days because you have other work too. Once it's built, it's good. And you can keep using that again and again and again and not investing huge amounts more time. You can improve the detector over time as things change. Maybe the design of street lamps indeed changes across your city and you need to, you now have 2 models that you need to find. So it could be increased or improved to find both. But overall, your time commitment is going down into the future, which is why this is a great tool for saving human energy.
Thanks, Caroline. Alexander would like to know also what are the benefits for the real estate market and if we check data?
Okay, for the real estate market, the main examples that I've been discussing are looking for land to develop. So being able to find maybe brownfield sites, potentially also greenfield sites, but let's say brownfield sites that are going to be relatively cheap to purchase and develop. So that could be things like disused factories, car parks, airstrips, things like that. Maybe disused sports grounds. So in each of those cases, you would set up a detector to find that kind of thing that you're interested in buying and developing land on. Another use case I've heard of is when people want to buy a property, well, more like you're selling properties and you want to advertise them as being close to certain facilities or having certain facilities. So you want to advertise the wealth of an area. So maybe you want to see how many swimming pools there are in that area, or how many tennis courts, or how close to schools or bus stops or train stations this new development is. You could do a mission to assess the value of a residential area by building those kind of high value object detectors. And yeah, showing that to your clients.
Thank you, Caroline, again. I have another question here. Christer would like to know if we have an existing workflow for Copernicus data that he could use.
So that would be the same as any data, actually. It doesn't really matter the source of the data. If you have the data already, you'll be able to upload it into our platform and already start annotating and building your own detectors. So maybe that's a question you'd like to email us about privately, Krista. We could get in touch after this webinar to discuss how you do that. But Copernicus data isn't different in the software's mind to any other kind, whether it be a different satellite or drone images.
Thank you, Caroline. Alvio has a very interesting question. He would like to know what would the best way be to count a whole lot of cattle or sheep? Should a person take individual photos of each lot of sheep or cattle, because creating an orthomosaic would create ghosting on the images?
Yeah, that's right. So if you make an orthomosaic, that's when you have lots of drone images and you stitch them together to make one large map or image. It will create ghosting, which means there'll be semi-objects appearing where an animal or a car or a person moved between 2 consecutive photos being taken. So what I would do in that case is create a detector, and then instead of running it across orthomosaics, I would run it across the individual images. So it depends then on how much overlap is counted between images. I think that's one way of doing it, or to build an orthomosaic, look for the ghosting effects and correct for them afterwards, saying we assume there's 90% accuracy based on the initial input data.
Thank you very much, Caroline. Farouk is wondering if we can monitor the crop rotation from satellite data.
Yes, so we mentioned this briefly before. Yes, you can. You would need to create a detector for each different type of crop. If you can see the crops from satellite data, which is always good to check in advance, then you'd be able to build detectors for each one, run those detectors every year to see in which fields those crops are now being grown, and therefore check that there was indeed rotation. So I think that would be very easy for highly identifiable crops, such as rapeseed oil, bright yellow, sunflowers are yellow. If it's variations of green, you'd need to yourself be pretty sure which crops you were looking for and how they appeared when you built the detectors. You could also use multispectral data or thermal or hyperspectral data. If those give you clearer representations of each type of crop, then you could use that data instead. It may be clearer for you to see and therefore design the detectors.
Thank you, Caroline. Sorry, we're shifting a little bit away from the construction topic, but that's all right. If you have any questions that are not related to construction, we're more than happy to answer them. And you can leave your email and we will contact you directly so we can set up a meeting for you so we can go deeper into your own projects. I have one more question. How can we do land classification by machine learning, and what are the parameters? What the parameters should be in?
Yeah, so land classification, I would say it again depends what classes you're looking for and if you can differentiate those as a human being from your images. That's actually always the rule of thumb. If you can see and clearly spot a pattern of the thing you're looking to find, you can teach the software to do it too. So if you're looking to find very specific classes, like different types of buildings or different qualities of tarmac versus bricked streets or something like that, you would probably need more accurate data like drone data. If overall you're looking to find where's generally an urban area versus open pit mining versus water versus trees, you don't need to see it in so much detail because it's just rough outlines of those areas. So then you could use satellite data. So what I'm saying is any class is possible to find as long as you can visually identify it in the quality of data that you have available.
Thank you, Caroline. Alexander just wants to double check if we check AI data manually.
So we are not involved at all in this process. This is you using the platform to design your own detectors. There are accuracy checks that you can do within the platform. So you can run a detector and compare it to how you would have marked the object of interest in that same area, and it will give you a percentage, both or percentage of accuracy. So both on the total area covered. So say I was looking for houses. I want to know versus what I say is the area of a house, how well did it outline that house? Is the area similar? And also, did it detect a house at all? So maybe it just missed a house and therefore that was, a mismatch. So it would give you the accuracy of both of those things, total count and total accuracy of area found. So that's the way you can test the accuracy. It's realistic to expect with good input data and good build of detector, upwards of 80% accuracy. For very regular objects like cars or containers, things like that, you could expect in the high 90s, but we can't ever guarantee that since they are built by you, the end user, and it relies on your quality of input data too.
Thank you. I have one more question from Jan. What is the effect of RGB versus grayscale to the success of the process, let's say with recognizing buildings? And what is the minimum resolution of imagery when recognizing objects of a certain size, for example, 1 square meter? Because sometimes areas are covered by different ortho photos of different colors. Would this require more examples to be entered?
I'll start with the first one about RGB versus grayscale. The software doesn't know what the difference is. So it's looking at collections of pixels and looking for patterns. So if you are able to teach it how to see something in grayscale or how to see something in color, it doesn't know the difference. If something's a shade of gray or it's green, it doesn't know the difference. It's just looking for collections of pixels that make up a certain object or a certain pattern. So that doesn't matter. It's more like, can you see it better in order to draw around things to teach it how to find things too. The resolution, it doesn't, I mean, again, it depends if you can see the object well enough. So there isn't like a number I can tell you that's perfect for a certain type of object. I'd say you want to see smaller things closer to the ground. It's like 1 meter. Downwards of 20 centimeters is going to be okay, 20 centimeter resolution. But it's very hard to say. I think it's just important to look on the images and see if you can see it to the accuracy you need. I feel like there was a final part to that question that I've forgotten.
Yes, the final part is about areas covered by different orthophotos of different colors.
Right. So when you create orthomosaics, the colors can be different depending on the direction the drone was flying when it took the images or some things like that. Often they are auto-corrected, but if they're not, you can get a field with suddenly 2 shades of green. In that case, it would be important to give examples if it really affects the way the object appears. So if you're looking for something that is suddenly appearing in 2 very different colors when it should be 1 color, you should give examples of both of the colors. Maybe a clearer example is if something is covered in shadow. You need to give examples of that object in bright light, in full shadow, and half shadow, so that it has plenty of examples of every way that object could appear in images.
Thank you, Caroline. So that's all the questions we have at the moment. If you have more questions, do not hesitate. Oh, you're welcome, Jan. You just wrote, thank you.
Thanks, Jan. You're welcome.
If you are interested, do we have a plugin to GIS? Yes, Krista, Caroline.
Yes, we do. Yes, we do. ArcGIS Pro and QGIS too.
If you are interested, I will put a link in the conversation here that can take you to Picterra University. So it's a lot of videos about not only the platform, but also remote sensing and all the technology that we use. It might be of interest for some of you if you want to, if you're curious about it. There you go.
Sounds good. And I think it's worth saying that this has been recorded and we'll be sending out a recording of this to anyone that signed up. So even if you're online now but want to watch this later, you can. All the other people that signed up and couldn't join today, thank you for watching later if you've got this far. Appreciate that. And yeah, look forward to continuing the conversation. So feel free to email any of us. Our individual names are always followed by @picterra.ch, or the general email address is hello@picterra.ch. And then you'll be directed to the right person.
So Radia, yes, we will definitely send you the this webinar. We will send it to everyone who has attended today. So like Caroline was saying, so you can watch it again if you have any questions. Thank you so much for attending today. It was really nice getting to talk about construction and remote construction monitoring. We will follow up with everyone after this webinar in the coming days or next week. So if you have any questions, if you want to discuss about a specific project or about specific technology or needs that you have, we can set up a demo anytime. We're always happy.
Great. Thank you very much for everyone who attended. Thanks to you, Samantha, for hosting. And,
thank you, Caroline, for answering all the questions and going into all the details. It was very interesting. Thank you, everyone. Thank you for your kind thank you notes at the end. It's very rewarding, and we look forward to the next one. And I think we'll wish you a good day or good evening from this point.
Good evening.
Good evening, everyone.
Bye-bye.
Thank you. Bye.